We're going to start off with the quiz. Don't worry, because all you have to do is respond with your face. How many of you like physics? Lots of frowns, 2 grimaces, and a couple of smiles from the engineers. Expected. How many of you like magic? That's a little better. I see Peter Pan. The problem is, Professor Fuller, in the Eastern Religions part of the University of Louisville, defines magic as manipulating the forces of nature to do the impossible. So the answer to those 2 questions should be the same. And what we're going to do today is to analyze 3 parts of physics to show the magic of it. We're going to look at something cool, something important, and something strange. So to start with something cool. Harry Potter is cool, right? We're just going to accept that. Specifically, every year for the last several years, when a big Harry Potter movie came out, science blogs around the world would come out with an article that said, "Physics makes Harry Potter real. Get your invisibility cloaks now," which is only partly a lie. Physics.org, a website devoted to making physics accessible to the general public, explains how this is done. And it starts out by explaining how sight works. So the way sight works is that you have light, it goes down to an object, and then it hits your eye. That's how you see things. If you want to make something invisible, like an invisibility cloak, you have to change that. So physicists have made something called a metamaterial, which is really fancy, but all it means is that whenever light hits the object, instead of actually hitting it, it bends it around to whatever is nearby it, and then it hits your eye. That way, instead of seeing the paper rose, I would see the brown part on the table instead. Now, why don't we have invisibility cloaks? The reason is there's more than one type of light. So if you've ever broken a bone, you had an X-ray, and that's a part of light that you can't visibly see. All the invisibility cloaks we have right now deal with microwaves and X-rays. But researchers at Boston University and Tufts University are making types of invisibility cloaks that actually deal with visible light. So you might see that sometime soon. But moving on from something cool to something important, the universe is dissolving into chaos. Which sounds dramatic, but is literally true. Engineering Toolbox, a website devoted to giving information to engineers around the world, defines it very simply. It states that things go from states of low entropy to high entropy. And what that means is things like to go from places of very highly organized states to unorganized states. And the reason behind that is that it takes a lot of energy to make something organized. So a house, for example, took a lot of effort to put up, but if you just left it over there over 100 years, it would eventually crumble. And in a very physical, real example, a paper rose takes approximately 88 folds to make, and for me, about 4 minutes to make. But, to take it apart, takes around a second. That's, in a very clear example, how you represent why the universe is dissolving into chaos in my hand. But that's really sad. So, we're going to move from something important to something interesting. And it's called quantum tunneling, which even sounds weird, but can be explained simply as well. Chuck Pearsall, who did his research at Stanford in their particle accelerator program, taught me physics, and he explained it very, very simply. The universe is governed by chance, and you can see that very easily, even in this room. The number of tragedies and miracles and all the strange things that have happened in all of our lives to bring us into this room seem wildly unlikely. And it's that same unlikely chance and probability that allows quantum tunneling to happen. Something that needs to be understood really quickly. So we have a wall over there, and the wall is composed of smaller parts of bricks. And if you looked really, really, really small, you would eventually see something like this under a microscope when you look at the wall, which is lots of tiny points and then big spaces where there are holes. What quantum tunneling says is that occasionally very small objects will go through those holes. And if you take a really, really unlikely option, so let's say 1 in a trillion chance, all of those holes would line up perfectly so that if you were to, say, try and run through the wall, you would actually go through it. And we're going to do an experiment, because this is a physics experiment. So, I'm going to toss a paper rose through the wall. And if it goes through the wall, I deserve an A. But there's only a 1 in a trillion chance of it happening. So I don't deserve an A for that. But it at least gives you a little bit of the magic of it. But that ends our physics lecture of the day. What I wanted to express today is that physics is not about equations or quizzes or the classroom. It's a way to understand the world and the magic that resides in it. We did that by looking at something cool, Harry Potter Invisible Cloaks, something important, everything's going to chaos, and something interesting, how you can run through walls sometimes. And that brings us to a close. I really like physics, and I know a lot of people don't, so I want to thank you for listening and hope that you might find things interesting in the future.